Right, we're back. Okay. I have scoured the internet and I can find nothing to tell me what is going on here. I believe there are, I'll let you see, hopefully you can see that. There are 3 coils over here and 3 coils here. And I believe that this is a 3-phase set of coils with the probably wired in a star connection with the single connection in the middle, or middle joint somewhere buried somewhere inside there. So I believe that's 3-phase there, and I believe that's 3-phase there, also with the star connection somewhere in the middle. And part of the reason why I believe that is because all of these 3 are shorting out, or very, very small resistance between them. And these are all very small resistance between them. No connection between the 3 sets. So, also, on the back of this, hopefully you can see that, it says 40 volts, 100/180 amps. Now, yeah, you can see that? Now, what I'm thinking that means is if we use one of these sets of coils, it's a 100 amp alternator, and if we need more power, then we can use the other set of coils, which gives us a 180 amp alternator. That is my theory, but what I cannot confirm one way or t'other is where the coils are going to be. And what I mean by that is, are they in phase? Are these 3 phases in phase with these 3 phases? And I suspect they may not be, because if we look at the alternator here, we can see 1, 2, 3, 4, 5, 6 diodes. We've got another 6 diodes here, and as far as I'm aware, for 3-phase rectification, which is what those diodes are for, you only need 6 diodes. So these 3 phases are rectifying through these 6 diodes. These 3 phases are rectifying through these 6 diodes, or something. Therefore, they don't need to be in phase, because ultimately all you want is DC out of this thing. So, too big a chance that the phases could be out of phase. And I guess from a smoothness point of view, that would make sense as well. So I don't believe I can drive this alternator using a single 3-phase controller. I don't think so. I could be wrong, but I'm not going to waste the time trying to work it out. So, wise man once said, if at first you don't succeed, try again. Yeah, well, he was an idiot. What you do is, if at first you don't succeed, cheat. What we have here is an alternator out of a VW. Hopefully you can see that. I'll lift it up. A VW Passat 180 amp alternator. And because it doesn't have 150/180 or 100/180, I'm hopeful that there are only 6 diodes in this, and we can make this work. Now, this looks like a brand new alternator, and I have to say it might as well be. But I only paid £15 for it, £15, and bought it from a chap. He had it listed on Gumtree, so I had to drive to his house last night to pick it up. It was only about 25 miles away, so 15 quid plus a couple of quid for diesel. That's not bad. I'll take that for something that's as good as this. So I'll probably speed this next bit up. So let's try and strip this down and see what we can find. If I can figure out how to take it apart, that is. What I should have said earlier is that this is an alternator off a Volkswagen Passat, I believe, which is a very, very common car. Volkswagen stroke Seat, so it's a really commonly available, widely available alternator. So should you be stupid enough to wish to copy what I'm doing, don't recommend it, but should you be stupid enough to wish to do that, there we go. You should be able to find one of these quite easily. And let's see what we've got. 1, 2, 3 large diodes. 3 wires coming out. Oh yeah, this is exactly what I was hoping for. Right, we've got, hopefully you can see that, you've got 3 very large, very beefy, heavy cables here that are coming out of this alternator, which means it is wired in star configuration. Guys, I'm going to butt in here and interrupt myself. I've just said that I think that this alternator is wired in star configuration, and I actually think I'm wrong in saying that. And the reason I think that is because since recording that video, I have purchased another alternator, the same model, taken it apart, and this is the stator out of it, and as you can see there is no sign of a large clump of wires all soldered together and tucked away somewhere. So in the absence of that clump of wires, I can only assume that this is wired in delta configuration. So it won't make any difference to how we plan to use it, but just so that you know, if you buy one of these alternators, it will probably come wired in the delta configuration. Okay, back to the video. So this is going to do our job, I think. It's a whole lot more simple than the other one, so let's get rid of that. That is now junk. So $8mm, I suspect. Nope, 6, 7, 7. Be nice to be able to take this apart without trashing it, but I'm not sure I'll be able to do that. I'll just do what I can. It would also be nice to be able to take this apart and leave a way of connecting to the phases without having to try and solder to those wires, because that's going to be difficult. I'd far rather just use the connections that are there. That would be much easier. Right, so oh, that's good. That is the brushes, and the brushes are, as I suspected, basically unused. It's like a brand new alternator. I can't believe I got this for so cheap. But the guy didn't want it, so you know, what do? You take it when you get it. Yeah, there are 3 diodes here, and there's 3 diodes here. 6 diodes, 3-phase rectification, perfect. What I would like to do now is to figure out, can we, oh sorry, just pop that off. They seem to be just pressed onto the diodes that are pointing up, so that should just pop up. Yeah, it's coming. Right. Come on, you piggy. As you can see, there's a little bit of oil on it. My hands, I've been handling this now for 20 minutes. My hands are clean-ish. You don't get that with alternators that are used. I can't believe the guy sold it as possibly faulty. He didn't know. I'd be very surprised if it is faulty, but oh, right. Okay, well, in doing that, I just broke the connection between these diodes and these connectors, but I'm not really too worried about that. I'm assuming that this is the voltage regulator. Don't really know. Just check what you can see. Yeah, I'm assuming this is a voltage regulator. Not sure. It was. Where was it? It was like that. Not sure. So let's see if this can force up. Okay, well, this is actually soldered to these, so I'll have to cut those connections. I could desolder them, but I'm not sufficiently interested to fuss about that. Can't believe those are just crimped around that. Those are just crimped around that. Without any great deal of physical strength, security holding them. That's a bit tighter. They're not soldered or anything. Maybe they are. Maybe it's part of the solder. Yeah, it's been soldered. Some of them are soldered better than others, mind you. Yeah, might get picky. There you go. This one's the only one that's properly soldered to the phase, which is a bit strange, but I don't really care. Right, so it looks like I'm going to have to just cut this off. I can't see any easy way of getting it off otherwise. Oh, there we go. Huh. Right, those are our connections to the phase wires. So these are our 3 diodes, and those are the other 3 diodes. So good. So this should be really easy to make into a 3-phase motor by just chopping off these diodes. I don't think there's any easy way to get them out. I think they're jammed in there tight. Right, so that's the diodes chopped off. Ultimately, I intend to replace the brushes with a magnet inside, a permanent magnet. That's the ultimate goal. But for now, I just want to get this working as a motor. So, to that end, let's get rid of these. Right, so they won't be affecting anything. I think ultimately the best thing to do would be just to go ahead and solder to this. It's not going to be easy, but we'll figure out some way of doing it. It wasn't very well soldered by the manufacturer, I can tell you that much. This is just annoying me. Don't need you. Right, let's see if we can open it up. Why not? That will be... Is that an image? Yep. I don't need to open it up at this stage because I can get access to the 3-phase wires anyway, but we'll just open it and see what options we have inside. Whew, that was easy. Right, so there's your windings. So this is the stator and this is the rotor, because this is the bit that normally rotates. Okay, so ultimately the plan is to remove that, pull the thing apart, pull the whole thing apart. It looks like it's... I'm not sure how easy that's going to be, but that's the ultimate plan. And once we have it apart, put the magnet inside there to replace the coils that are going to be on this rotor. So let's get that back together again, and we will... It's very, very easy to take apart. We'll get this back together and we'll get a controller on it, and we'll just confirm that we can spin it up as a motor, because at the moment we don't, not 100% sure. 90%, 95% sure, but not 100%. So we'll get it spinning as a motor and then we'll take it from there. I think I'll put these, try and slip these brushes on. This is going to be easier said than done. How do you... I didn't think this one through very well. How does that pop off? Looks like it might. Right guys, the problem we have here is that we're trying to pull this back down and put that over the top, but this is the piece of wire that I have is very strong but it's too thick, so I'm going to grind it down. I'm just trying to flatten this so that it can squeeze in there. Okay, let's swing you back and let's see if this does the job. Of course I hadn't thought about getting the blinking thing out. How on earth? Okay guys, sometimes a quick check on the internet is the way to go in this. Basically what the guy on the internet was saying was there's a little plastic cap there, just break it off. This little plastic piece here, just break it off. and then it's not going to foul on the brush, which means that that can slide up. But I think there's another one, so I need to push this one down out of the way completely. And yep, there it is there. I don't know if you can see that or not, but inside there's another little piece of plastic, so get rid of that. And now that that's out of the way, this plastic cap should slide off. Obviously this would be a little bit easier on a used alternator with worn brushes, but there you go. And that's the plastic thing I was talking about. So that is now, just cut that off completely. Right. Okay guys, now we have the cap off, we can refit the brushes, but first we need to refit this somewhere. It doesn't help when you're an idiot. Let's just make sure we're not getting any silly resistances on our setup. What are we getting? Just put the ohms. Yeah, we're getting pretty much a short circuit on those coils. Not quite short, but almost. 1 or 2 ohms maybe. Same here. Should be basically the same resistance across all 3 of these, which is 0.5, 0.5, and this should be 0.5 also. Basically a short circuit, because that is just windings. And the same across these, basically short circuit because they're just windings. It's actually about 2 ohms. So if that's about 2 ohms, put 5 volts on that. I equals V over R. 5 over 2 is 2.5. Put 5 volts on there, is 2.5 amps approximately going into the brushes. That's my theory anyway. And once you have the brush assembly fitted, then just take your cap and push it back over. Just like that. Right guys, well, back again with the some wires to put onto this. Now these are, I believe, 4mm squared, so probably not, they're heavy enough duty for this job, because this is probably not going to be drawing more than 500 watts at any stage, and these are wires capable of carrying kilowatts, so not a problem there. If I was going to use this in something that was drawing maybe 3000 watts or something like that, I would use heavier cable, but I think for this these will be fine. I'm going to use this soldering iron, which is a bit of a beast, to be honest. I'm not sure exactly what wattage it is. I think it's maybe 150, something like that. Not sure, but anyway, we're going to use this iron when it gets warmed up. I've already put some flux onto the connections here, so you can pretty well see everything that's going on there. That's good. What I'll be doing is turning this around once I get the wrap that around. I should have done this in the first place. Wrap that around sort of like so, and like so. Yeah. Okay. And put some of our flux on there. And that's physically wrapped around there. Now if I was to put the solder on, that would be a much stronger connection. Right. That's going nowhere now. Hey, now we're sucking diesel. That's the way to do it. And apply heat. Okay, that's it hot. And same again. Sweet. There you go. There's 3 terminals really well soldered on. They're not going anywhere. Good. So now what I need to do is to solder to these two. I'm going to use this, which is well over the top. It's actually very stiff. I might not use that actually. No, that's too stiff. Let's see if I can find something nicer. Right, I couldn't find the wire I was looking for, guys, so this will do. Bit of 3-core flex. Obviously we don't need the earth in this occasion, so we'll just whack that off. This is, I believe, 1.5 millimeter squared, which is more than enough for what we're doing here. 5 volts at, what did it say? 6 volts at 6 amps. It's not very much current to worry about. So this will do the job. So I just need to solder onto those 2 jobbies there. Right. So that's our 2 wires for the to excite the coils. Cut them all about the same length. There we go. In fact, let me just pull it. Yeah. Obviously twisted down the wire, down the insulation. There we go. I should have done that before I started soldering. Anyway, there we go. That should be alright. Put our 5 volts onto these. So what I'll do now is I'll pause you and we'll come back and we'll have the e-bike kit set up. Okay guys, so here is the e-bike controller. A mess of wires as you can see, but this is the 3-phase connections, so I'll just fire them into this quickly. At this stage the colour doesn't matter, but I might as well keep them the same because I've no way of knowing what the phase connections need to be, but with these cheap e-bike controllers it doesn't matter too much, they just work anyway. If I need to make the motor run backwards, or if I need to make it run the other direction, all I need to do is change over 2 of those phase wires and it'll run the other direction. Right, so that's that done. That is my battery. So the battery can connect to this. Yep, battery can connect to that. Then I just need the 6 volts. So I need to find my step down transformer or buck converter for that. So hold on, I'll come back when I get it. Okay, right, I've found it. This is the 36 to 5 volt or whatever volt converter that I was using. It's actually a motor controller, a DC motor controller, and basically you put your high voltage in there and you connect your motor to there. Once again, polarity does not matter, but we may as well stick with what we've got. That will now provide a voltage, small voltage, to the rotor. It's just I need to put power to it. I need to connect these power connections to this. Right. Right, so this is power from the main battery. I know it looks a bit confusing, but all will become clear. Let's put it in here. And main pause. Right. Okay, so basically make sure you can see everything I'm doing. Right. What we've got is a battery which is providing 36 volts, and that battery, which is currently turned off, can be plugged into this connection, which will give 36 volts to the controller there, and 36 volts to this block, which puts 36 volts to this motor controller, DC motor controller. I'll just put that lid back on there. Right, so this has 36 volts and this has 36 volts. The motor controller, this DC motor controller, I can set to be whatever voltage I wish it to be. So if I put that on, and I want that to be, well, let's just get our voltmeter. Put the voltmeter to volts, DC. Turn it off now again. Put the volts DC. We can now check and see what voltage we're getting. And we're getting 4 volts. So if I turn that knob, there's 6 volts, give or take. Right, so that's plenty, that's fine. We can turn it off again. That should be no volts. Correct. In fact, just turn off the motor and leave that on. Right, okay. So that's putting 6 volts DC to this, to the brushes here, which goes through to the rotor, which gives the magnetic field on the rotor. So this is the connection, then putting the 3-phase wires to the controller. So my theory is that should be ready to go, except I need a throttle now. Forgot about that bit. Right, put you in hold, we'll go and get a throttle. Right guys, I found one. I thought I had another one somewhere that had the correct connector on it, but this will do the job for now. For the purposes of testing, I'm just going to use an old e-bike throttle, and on that throttle you have, forget about those wires, you have red, black and white. Red and black are your 5 volts coming from the controller, and white is the wire coming from the Hall effect sensor, which starts off I think about 0.4 volts or 0.2 volts, something like that, and goes up to 4 point something volts when it's on full power. So what I need to do is get these connected to this socket, and one of these sockets is the throttle. It'll be the one with 3 wires on it, this one. So I think the best thing, it might be easier just to put one of these connectors on here and then we'll have it handy. So I'll just go ahead and do that. You don't need to see me doing it, it's just putting a connector on. Right guys, back. I just saved you the pain of watching me puckle around with the fitting this connector. So the theory is this e-bike connector can go onto here. That will connect e-bike throttle to e-bike controller. We already have 6 volts and we have the controller connected. So my theory is that this probably won't work. It might. It's supposed to be a 36 volt controller as well. I'm not sure. We'll just see. So if I turn that on, that has put 5 volts to there. So if I do this, it works. Hey! We have spinny spin. Right. There you go. You're a witness. It worked first time. So what I can do is I can play with the voltage that's going to the rotor, if I wish. At the moment there is 16% of 36 volts going to the rotor, and I could turn that down to say 10%. So that should be approximately 3.6 volts going to the rotor. We can just check that with the voltmeter. I need to get this tipped over. Excuse me a second guys, I'll tip this over. Right. The battery might be dying on our meter. Right, we're at volts, DC, and we are getting 3.89 volts going to the meter, 3.9 volts to the meter. And since the controller, the battery is delivering 41 volts, and this is claiming to be 10%, that's not too far away. Just in case you're confused by what I'm talking about there, this this DC motor controller that I bought off eBay for 20 or 30 pounds, I can't remember exactly how much it was. The way it works is there's a knob on the end and you turn the knob to turn the voltage up and down that it sends out, and the voltage up and down is displayed, instead of displaying the voltage, for some reason they display the percentage of the incoming voltage. Don't know why. So we now have about 4 volts going to that, and that should still work, yeah. So there you have it. The 180 amp alternator from a Volkswagen Passat or Audi A3 probably, or Skoda Octavia. Probably most of those cars will have a similar 180 amp alternator, so there's lots of them out there. They're cheap on eBay. You can buy them from £20, $20, that sort of money on eBay, or go to your local scrapyard and buy it from them. They're really, really cheap because there's loads of them out there. This will, as an alternator, handle 2500 watts. So as a motor, it should also handle something similar, around about the 2500 watts, give or take. That's interesting. That spins a whole lot freer with the voltage turned down. If I put that back, oh, it's turned off. Sorry. Yeah, when that's turned on, you can actually feel the cogging of the magnets inside. So that is working perfectly as a motor. It is a tad noisy, as you can hear. Now, a lot of that noise is coming from the fact that this controller is a very cheap, nasty square wave controller, and a square wave going into a motor, it doesn't like it. It would rather have a nice smooth sine wave. So the plan is to take this apart, fit a magnet into it, just an ordinary, well, it's a large ring magnet. They're hard to get, but I think I've managed to source a supplier. Put a magnet into it, install Hall effect sensors, which is in the laminations, which is not simple either, but it can be done. I've seen it being done by other guys on the internet. So put in Hall effect sensors and a permanent magnet, which would mean I wouldn't need this anymore, and I would be able to use a sine wave controller which requires Hall effect sensors. These cheap square wave ones don't seem to mind. They'll just drive any motor. But anyway, that's good. We're making progress. We've got a good working alternator, motor alternator, whatever you want to call it, multi-motor, working well and doing everything I want. So now I can see about getting this installed in the car, and that's coming next.